Let's go ahead and go through the functions quiz. We'll start with number 1. Number 1, it's asking us to compare two equations, and they're written in y equals mx plus b format, even though it may not appear it, like especially right there, y equals x. This part right here is our slope. Okay, another word for slope is how steep the line is, so we're looking for how steep. And this part right here is the y-intercept. In other words, how high is it? Okay, so we want to know, is it really steep and is it higher than each other? Now, a thing here is if I have a -5 for my slope and a 3, the negative just tells us which direction it's going. It's either going that way or up or whatever. So we don't need to worry about that with how steep it is. All we have to pay attention to is the number. So the -5 would have a steeper slope than the 3. With that in mind, I want to look at this. Now I have y equals x. That's that first equation right here. I'm just writing it up here. Y equals x. Now if there's no slope right here, or y-intercept, excuse me, then we're just going to always put a +0. And if there's no number for slope, it's always just 1. And if you think about it, it's just 1x. And that's how we get that number. Okay, so this equation and y equals x are the same thing. Okay, that and that are equal. Let's go ahead and compare them. What we're asked to compare is y equals 1/5 x. So I'm going to write it right below it, 1/5x, and there's no y-intercept anywhere here, so I'm just going to put a +0. And now we're going to look at the questions. Which one is steeper? Compared to the top one, is the bottom one steeper, not as steep, or equal? Again, we're looking at the slope. In this case, the slope is 1, and in this bottom one, the slope is 1/5. 1/5 is smaller than 1, therefore it is less steep. Okay, and the next one, the y-axis. They both intercept at 0, so they're at the exact same point. Okay, now let's do the next one. We got y equals x, and we have y equals x plus 2. Okay, again, if we don't have a slope there, we can just put a 1. And if we don't have a y-intercept, we can just put +0. Now we can compare them. Compared to the top equation, the bottom one is the same steepness, right? 1 and 1 tells me they are equally steep. And the y-intercept, compared to the top one, the bottom one is higher. So it's crossing at a higher point. This next one is the same type of problem. We'll go through it and see, okay, we have y equals x, and again, we can add the 1 and the +0. And then we also have y equals x minus 4/3. And we don't have a number here, so I'm just going to put a 1. And now we can compare them. Compared to the top one, the bottom one has the same slope. See that? They're both 1. So they're equally steep. Compared to the top one, the bottom one is at a lower point. And if we look at that, we can see, hey, negative numbers, here's 0, negative numbers go below 0. So that means it's lower than 0. Okay? And the last one on this type of question, we have y equals 2x, and I'll put that back in blue. and then we have to add the plus 0. It's not already added, so we'll add that in, and now we can compare them. Compared to the top one, the bottom one is steeper. That number is higher than 1. So we're going to change that to steeper. And they're both intersecting at the exact same point, so it's at the same point. And that's how you do it. You're just looking for how you're comparing the slope, and you're comparing where they intersect. And that's almost always what you compare when you're dealing with functions. Number 3. Here we're given a story problem. And with the story problem, it's very important to try to put yourself logically into the problem so that you're not concerned with the math, or you're not confused with the math. You're dealing just with the problem, and you put yourself into it so that you can kind of visualize what's happening. In this situation, we have a car rental company, and they have a standard charge that includes an initial fee plus each mile driven. And here's that equation right there. So when I walk in the door, I have to pay $17.75 plus every mile I have to pay 60 cents, so 0.60 per mile. Okay, and that makes sense. This company also offers insurance. Now the insurance charge is given right here, and we can see, all right, that's $3.70 just to have it. So we're going to say, all right, $3.70 plus they charge 25 cents per mile. Now with that in mind, we look at this and we think, all right, logically, what's going to happen? We're renting the car with insurance. If we're renting it with insurance, then we have to pay both of these, right? We have to pay this for the car and this for the insurance. If we add them together, we get 5, 4, 1, and 2, 21.45. And if we add these together, because we got to pay for both of them now, we get 0.85M. And that's all it's looking for. It wants us to simplify it as much as possible. We can't simplify it any more than it is right now. So we just type it in exactly as we see it. Same type of question here. Omar and his wife are each starting a savings plan. So again, we have Omar over here and his wife over here, and we'll give her curly hair. And they're both putting money into the savings plan. Now if you think about it, whatever he adds will go into the plan, and then whatever she adds will also go into the same plan, so that it's adding everything together to get that plan. So Omar initially puts $75 in. So our account now has $75. And every week he adds $40.75 every single week. Now his wife, and that's the equation we have here. Only I forgot the N for weeks. Now his wife won't be doing any initial amount, so she doesn't put anything in at first, but she does add $75.65 every single week. Okay, and we see that's the same equation they came up with right there. Kind of scribbled on it. So that's the equation they have right here, only I have that 0 plus. Now if we want to look at it, we're trying to find out how much is saved using both plans combined. So when he adds his 75 to her 0, that's still 75 plus, and we have his weekly of $40.75 and her weekly of $75.65. How much is that total? That'll turn out to be 0, 7, 8, and that's 13, 14, and 6, and 11. So every week they're putting in a combined total of $116.40. Okay, and that makes sense. Every week that's what goes in, and it started with that much, and we can't simplify that anymore, so that's exactly what we type in. 75 plus 116.40 n. And that's how we solve those story problems. Just put yourself into it and try to think logically. Number 5. This type of problem deals with domain and range. Please remember Rangy the dog. Oh, Rangy, Rangy, why are you so ugly? So try to think of that. Domain is X and range is Y. So domain is X and range is Y. Okay. Now, when you're dealing on a computer, domain is always in brackets every single time. Same with range. You always want to put range in brackets, just like that. Just one set for the whole group of numbers. Now, domain is always X, and these numbers are in ordered pairs, X, comma, Y. Now, I wanted to explain the difference between a relation and a function. A relation is just a group of ordered pairs. It can be any group of ordered pairs, it doesn't matter. A function is a relation, but all the x's have to be individual. So you see here we have the 1 and the 1, but with different y's. That means what I have here is not a function. Okay? But it is still a relation. Okay? So a number can be not a function and a relation. So anyway, a relation is just a group of ordered pairs. That's all you have to worry about. So domain, we're going to look at all our x's right now. So what's our first x? Initially, you would think 7. But that would be wrong. Okay? Now, the reason why that's wrong is because domain always has to be, and range, always have to be in order from small to big. Always from smallest to biggest. Okay, so in here, what's my smallest number? It would be -2, comma. What's my next smallest? It'd be 1. Now we see here we have 1 listed twice. We don't have to list it twice. We just put it in the list once. And then my last one is 7. Okay, now for range, we're doing the same thing, but with y. What's my smallest y? It would be -2, comma. What's my next smallest y? It would be 0, then 3, then 6. And it's okay if they're different sizes, because this one has 2 1s and we only need to list it once. So that's how you deal with domain and range. In this question, we're asked to compare 4 different functions, 4 different functions. What we're being asked to look at is, and this is with any function, when you're comparing functions, you want to compare slope and y-intercept. In other words, how steep and how high. Okay? So in this case, what's our slope? Our slope is going down 1, 2, 3, and over 1. So -3 over 1, which is -3. And if you think about that, -3 over 1, -3 divided by 1, that's where I get the -3. Now our slope for a table, we have to watch or look at the change in y over the change in x. Okay, so what's happening with y? It's going down by 5 every single time. So -5 over, and this is going up by 1, so 1 What's negative 5 divided by 1? It's negative 5. Okay. Here, our slope is given to us right there, so it's 4. And here, our slope is given to us right here, and it's 1. Now this first question, which graphs have slopes greater than negative 4? So what numbers are greater than negative 4? Is negative 3 greater than negative 4? Yes, it is. Now in class I taught this wrong, and I'm going to add a couple points to everyone's quiz as a result, but it's actually asking for which slope is greater than that actual number, not a slope of that number, but which number is bigger than negative 4. So function 1, that is greater than negative 4. Function 2, that number is less than negative 4. Function 3, that number is greater than negative 4. And function 4, that number is also greater than 4. Negative 4. Okay, which function, let's skip to this one really quick. Which graph is steepest? Okay, so here we have some slopes and we ignore the negatives. So we have 5, 3, 4, and 1. Which one is the highest number? Well, that would be the 5, so function 2 would be the steepest. Okay, now we're dealing with y-intercepts. Y-intercepts is just where it crosses the y-axis. So right here, y-intercept is right there, right here. And on a table, the y-intercept is whenever x is 0. So right here. Now, which one is farthest away from 0? Well, that's 4 spaces away. That's 5. And so 5 is the winner. 5 is the farthest away. So we're just going to put negative 1, or function 1, excuse me. Number 7. Same type of question. 3 parts. Okay. Here we have our positive 2 is, I'm looking for slope. We got negative 3 for slope. Slope is 4. How is this changing? It's going down by 5, so negative 5, and this is going up by 1, so negative 5 over 1, and this is up 1 over 1, so this has a slope of 1 over 1, which is 1. Okay. Now the question, which function is least steep? So which one has the lowest number in the slope? This one has a 1, 3, 4, and 5, so function 1 is the least steep because it only has a 1. And again, we ignore the negatives on slope for when we compare them. Which graph has the greatest slope? So it's not 1 because that's got the least, so we've got 3, 4, and 5, so function 2, that's the highest number, or farthest away from 0. Okay, which function intercepts or have y-intercepts less than 3? So here's our 3. This one's less than 3. That's less than 3. That's less than 3. And that is not less than 3. So all of them except for the last one are the correct answer. Now in this one, if you have a calculator, it's very useful to use. For example, if I have my calculator here, I want to hit y equals, so let's just get back out to the normal. I'll push y equals right there, and then I want to enter this equation right there. Okay, so I'm going to hit 3 raised to the x power. Once you've done that, then you can hit second graph, and that creates a table for you. See where it says table? And there's my table. And I can scroll down and I can fill in all the pieces that it wants. It wants me to plug in 4, 5, 6, and 7 for the graph. So I take 4 right here, and I take this number and put it in place of 4. Okay, and then same for 5, 6, 7. So just like that, I've got all of them plugged in. All I did was one at a time. I added in each number, starting with my 4, plugged in 4 and got that, and then that, and then that, and so on. Now, if you don't have one of these calculators that can do the graph or the table for you, that's fine. Let's look at this next one. I have 15x squared. What's the first x I'm putting in? Is 4. So 15 times 4 squared. And 4 squared is 16. 16 times 15 is 240. And I can do that with each one of them. 15 squared, or excuse me, 5 squared. Remember, you got to do the squared first. So 5 squared is 25. 25 times 15 is 375. 6 squared is 36. 36 times 15 is 540. Next one is 7 squared is 49. 49 times 15 is 735. So you can do it. Just remember your order of operations. Exponents always comes first before any multiplication. So now we look at for x is greater than negative 4. So in other words, we're only looking, or not negative 4, excuse me, greater than or equal to 4. So we're only looking at these numbers and beyond. It wants to know how often f of x is less than g of x. Is it always, sometimes, or never? So here we see it is less than. Here it is still less than, and now it's greater than. So that means it is sometimes less than g of x. Number 9. This is a story problem which panics most people, but it really doesn't need to. You're given the equation, and we're talking about a gift card at a photo center. It starts at $35, and she's already used 20 cents per print. She's using it to buy 20 cents per print. And we want to know how much is left. Well, we don't know how many prints she bought, so that's where the function b of x comes in, where x is the number of prints. Okay? X is the number of prints. So that's the same thing as saying b, the function b of prints. Okay? Well, how many prints does she want? She bought 30 prints. So we're replacing that with b of 30. That means that 30 needs to go right there. And we have 35 minus 0.20 times, parentheses times 30. Don't forget the parentheses. Now, 30 times 0.2 is 6, and 35 minus 6 is 29. Okay, and remember order of operations, we're doing the times first and then doing the subtraction. So $29. Now this one. Okay, we're dealing with f of x, where we're replacing x. Okay, what are we replacing x with? 0. So we want to go back and forth on x until we find 0. And then where's the line on that? If we go up, we see the line touches right here at 1. So when x is 0, the answer is 1, or y is 1. Okay, the next one is very similar, but it gives you an extra part. Again, we're replacing x with 2. So we're going to look at 2. When x is 2, what is y? What is the answer? The answer is -2. Okay, so you see it's like a times table where you just find where they cross based on the line that is drawn. Now this next part can get confusing if you don't remember that f of x equals y. They're the same thing. That is y. They're exactly the same thing. So here we're saying, give me a value of x when y equals -4. Well, y is -4 right there. So what is x? 0. 0, -4. So I'm going to put a 0 right there. And that's how you do that kind of problem. Now this next one here is based on domain and range. And there's two ways to write domain and range, and we've always dealt with infinity and stuff like that. But I want to show you domain and range, it's always lowest less than whatever variable it is, less than highest. Now this can also be less than or equal to. Nice and neat there, isn't it? Less than or equal to. So that can change based on whether or not the dot is filled in or not. In this case, they both are. Now what happens if your highest is infinity? Normally you would write lowest, less than or equal to x, less than or equal to infinity. But in this case, if we look here, infinity is not one of the options given to us. So if that's the case, you just ignore that top part right there and just write infinity. Okay? Now what do these all mean down here? Empty set means there's nothing there. Well, we have a domain and we have a range. If it were an empty set, it means it would be a blank graph. So empty set means no answer, no number. All reals just simply means that if it had an arrow on both sides, it would include all real numbers. Okay? So let's look at range. Range is our y. What is the absolute lowest it goes? It goes all the way down to 0. So I'm going to put the 0. And is it a dot? Yeah, it's a filled in dot, so it's inclusive. Always less than. Sometimes less than or equal to, but never ever greater than or equal to. Okay, now what are we dealing with? We're dealing with range, so that's always y. What's the highest value? It goes up to 175, and that's a filled in circle, so I'll include that as well. Okay, domain, what's my lowest x? It goes all the way down to 0. It's always less than or equal to, and we see here it's a filled in circle, so it's less than or equal to. We're dealing with domain. It's got a filled in circle for the top, so I'm going to use a less than or equal to, and it's less than or equal to 35 is the highest that x goes. Now this is probably the easiest one of all of them. It wants to know from A to B, is it increasing, decreasing, or neither? Well, from A to B, it's flat. It's not increasing or decreasing, it's constant. Okay? Now B to C, it's decreasing, it's going down. From C to D, it's increasing, it's going up. And from D to E, again, it's going down, decreasing. So you just got to find out if it's going up, down, or flat. And that's what these mean. This just means up, flat, or down. Now this one, we've just got to find a scenario that matches. When you look at these, always look for the x-axis and the y-axis to see what they mean. X is usually always time. Well, time always has to start at 0. You have to have a beginning point. Remember, the y-intercept is always our beginning point. So we can look right away to see if any of them don't have a beginning time, and we see right here this one can never work because it has to have time moves like this, not just instant. Okay, so both of these deal with time that don't go to the y-intercept. Okay, so that one's something you got to look for, is does it go to the y-intercept? Now, a passenger plane flies at a constant speed. So we see here y is the plane's speed. Well, in this case, the speed is going down, so it's decreasing, and that's not what it says. It says it's constant. We already figured out that wasn't the answer. This speed goes along flat at a constant speed, and that's exactly what it's looking for right there. Okay, this next one, we already figured out this wasn't it. Laura walks from home to school. Now we see that the y-axis is her distance from home. So when she starts from home, she's starting at 0. She's at home. And then her distance gets higher the farther away she gets from school. So this one, she's getting closer to home. This one, she's constantly the same. This one, she starts at home and works and walks to school, so she gets farther away. And so that's the only one that makes sense. Now this next one is exactly the same, just a little harder because the arrows aren't straight. But we can still solve it the same way. Can we eliminate anything for not going to the y-axis? And the answer is no. Everything goes to the y-axis. Good. Hans is driving at a constant speed. Okay, so we see here the y-axis is our speed. So here, is this constant? No. Is this constant? No. So it's not this one, not this one. Is this constant? Yes. And right here is constant. So yes. He then slows down to pass an accident. So his speed then decreases. So here is where his speed decreases, or he slows down, so that must be the answer. At a sightseeing ship, or a sightseeing ship is stopped in the water for an hour. Okay. So here's our distance to shore, and we already saw the time. So distance, if it's stopped, the distance isn't changing. So here the distance is constant. Here it's stopped, yet it's getting farther away from the shore, so that can't be it. Here the distance is constant. Here it's getting closer to shore while it's stopped, and that can't be the answer either. Okay. Then the captain heads the ship back to shore at a constant rate. Okay, so we're getting closer to shore, closer to shore. And this one gets closer to shore too, so we got to keep going. The ship docks at shore for a while, so the distance from shore when it's docked should be 0. So he never actually gets to shore right here, and therefore that can't be the right answer.